Have you ever found an article with an incredibly exciting headline, but with content that leaves you disappointed? Congratulations, you have become a victim of clickbait. Clickbait is essentially using incredulous-sounding titles to bait people to access the article page, usually for ad revenue. The actual article itself is usually shoddy journalism that hardly tells you anything of use, and thus is a waste of time. Clickbait also contributes to the spread of fake news. This got us thinking about whether we could use our understanding of machine learning concepts to automatically detect clickbait articles using their headlines and content. We came across the Clickbait challenge, which provides a large dataset of articles which have been classified into clickbait and non-clickbait based on crowdsourced responses. The dataset that we have used has a lot of information, such as the article title, content, label, etc. We used a two-pronged approach for this problem. Firstly, we use the traditional machine learning approach, which is to engineer our own features from the dataset and train our models on them. These features are what we believed help to separate clickbait and non-clickbait articles. Some features we considered were proportion of proper nouns in the content, proportion of question marks in the title, whether the title starts with 5W1H, etc. Next, we used a deep learning approach, where we passed the article title into a deep neural network, hoping that the hidden layers can learn the features for us. For the traditional machine learning approach, we used the following models: logistic regression, naive Bayes, KNN, random forest, and bagging. For deep learning approaches, we used a neural network, a convolutional neural network CNN, and recurrent neural network RNN. For CNN, the hidden layers learns local features from the article title, whereas for RNN, the hidden layers learns how the previous word in the title is related to the next word. After weeks of toiling, excitement, and disappointment, we finally got the results of the various models that we have used to identify clickbait articles. We used both classification accuracy and F1 score to evaluate our model. Classification accuracy, which are the blue bars, is the number of correct predictions made divided by the total number of predictions made. The F1 score, which are the green bars, is another measure of a test's accuracy. It is calculated using the precision and recall. Precision is the proportion of predicted positive results that truly are positive. Recall is the ability of a test to correctly identify positive results to get a true positive rate. The best F1 score is 100%, while the worst F1 score is 0%. From the results here, we can see that the RNN model performed the best, with an accuracy of 68.9% and F1 score of 67%. In conclusion, we applied both traditional machine learning techniques and deep learning to try to automatically classify articles as clickbait or non-clickbait. Our results show that the RNN model performed the best. In the future, we hope to improve on our models so that we're able to identify clickbait articles more accurately than what we have done so far.